Imagine for a moment that you are standing in a world that is rapidly running out of options. For centuries, the progress of our species was limited by the physical boundaries of the natural world. Every bit of work you see, every structure built, and every field plowed is powered by something that eventually gets tired. In this era, muscles are the only currency of movement. Horses need hours of rest and vast quantities of hay just to perform a few hours of labor. Water wheels, while powerful, are entirely at the mercy of the seasons, standing frozen and useless in the depths of winter and remaining bone dry and stationary during a summer drought. Human beings can only lift so much and work so fast before their strength fails. For hundreds of years, this was the invisible wall that humanity could not climb over. We had the dreams of grand machines and the desire for global trade, but we simply did not have the collective muscles to make those dreams happen. In our last look at this era, we explored how the technical invention of a separate condenser allowed engines to stay hot and efficient for the first time. That specific fix changed the physics of what was possible, allowing factories to finally move away from the riverbanks and into the heart of society. But while the science was revolutionary, there was another battle happening in the background. This was a high-stakes race against bankruptcy, desperate rivals, and the relentless ticking of the clock. This race took place in the smoky, dimly lit workshops and the damp, dangerous mines of the late 1700s. At the time, the biggest problem facing the industrial world was not a lack of ambition, but a surplus of water. It sounds simple, but it was a true crisis of survival for the economy. To get the coal, iron, and tin needed for a growing society, miners had to go deeper and deeper into the earth. The problem was that the deeper they went, the more the earth fought back by flooding the tunnels with cold groundwater. If the water could not be pumped out faster than it flowed in, the mine had to be abandoned, and a massive source of wealth and fuel would be lost forever under the rising tide. The existing engines of the day were massive, clunky, and incredibly expensive to run. They were so inefficient that they could really only be used at the mouths of coal mines, where fuel was basically free because it was right there on the ground. If you wanted to use that power anywhere else, the astronomical cost of hauling coal to the engine would bankrupt any business owner. The world was stuck in a loop. We knew the power was there, hidden in the steam, but we could not figure out how to make it affordable or reliable enough to change the world. The turning point in this story is not just a single moment of inspiration in a quiet lab. It was a decade of desperate experimentation and a massive gamble that almost failed multiple times. The inventor behind these improvements was not a wealthy man or a titled scientist. He was a humble maker of mathematical instruments who saw a mechanical problem and could not let it go. He realized that the way we were using steam at the time was fundamentally broken. We were heating a cylinder with steam and then immediately cooling it down with cold water to create a vacuum, wasting almost all the energy just in the process of reheating the metal over and over again. His idea to keep the cylinder hot while condensing the steam in a separate vessel was brilliant, but ideas do not pay the bills. He spent years in crushing debt, struggling to find the right materials and the right partners to bring his vision to life. He was in a literal race against other inventors who were trying to patent similar ideas or find their own ways to bypass the limitations of the old designs. If he did not get his version to work and prove its worth to a skeptical public, someone else would claim the future, and his life's work would be forgotten. This is where the story shifts from a lonely inventor in a cold workshop to a massive industrial partnership. To win the race, he needed someone who understood the market and had the deep resources to build on a truly grand scale. He eventually teamed up with a bold and charismatic businessman who saw that the future was not just in making a better pump for a few mines, but in creating a whole new category of power that could be sold to the entire world. However, even with funding, they faced a massive technical hurdle. It is one thing to make a small model that works on a wooden table, but it is another thing entirely to build a massive iron machine that does not leak steam under pressure. At the time, We did not have the tools to make perfectly round metal cylinders of that size. If the piston did not fit perfectly inside the cylinder, the steam would escape through the gaps, and the engine would lose its strength and efficiency. They had to push the limits of what metalworkers could do, demanding a level of precision that had never been asked for in the history of human manufacturing. This demand for accuracy actually helped jumpstart the entire field of precision engineering, as they searched for the one craftsman who could bore a hole through iron with the accuracy of a gun barrel. The year 1776 is often remembered for political revolutions and the birth of new nations, but it was also a year of mechanical revolution that would have an equally profound impact. This was the year when the first of these improved, highly efficient engines actually started working in the real world. One of them was used to blow air into a massive blast furnace, and another was used to pump water from a deep mine that had been considered lost. The results were staggering to everyone who witnessed them. These machines used only a fraction of the fuel of the older models, yet they worked with a strength and consistency that seemed almost magical. But the business partners were clever in how they introduced this to the world. They did not just sell the machines for a flat, high fee that few could afford. Instead, they came up with a revolutionary system where the customer paid a portion of the money they saved on fuel compared to the old engines. This was a completely new way of thinking about value and service. It made the technology accessible to people who could not afford a massive upfront cost, but desperately needed the power to keep their businesses alive. It was a win for the inventors, a win for the owners, and a win for the rapid expansion of industry. As these engines began to spread across the landscape, the very pace of human life changed forever. Before this, the world was relatively quiet and followed the ancient rhythm of the sun and the changing seasons. Now, there was a steady, rhythmic thud of metal on metal that never had to stop for rest. These engines were standardized and predictable. For the first time, a business owner in one part of the country could buy an engine and know exactly how much work it would do compared to one in another city, hundreds of miles away. To help people understand this new, abstract power, the inventor created a comparison that we still use in our daily lives today. He calculated how much work a strong horse could do in a day and compared his engines to that familiar standard. This gave people a mental bridge from the old world of animal labor to the new world of mechanical force. Suddenly, people were not just buying a machine. They were buying the equivalent strength of 20, 50, or 100 horses that never got tired, never needed to be fed when they weren't working, and never died of exhaustion. The ripple effects of this efficiency were felt everywhere. Because these engines were so efficient and did not require a nearby coal mine to be profitable, they could be placed anywhere, not just near fuel sources or riverbanks. This led to the birth of the modern industrial city as we know it. Factories were built near ports and transport hubs, drawing thousands of people from the countryside who were looking for a new way of life. This shift created a massive social transformation that had no historical parallel. It changed how families lived, how they worked together, and how they viewed the passage of time. The race to improve the steam engine had accidentally created the modern world of scheduled shifts, factory whistles, and urban living. It also triggered a secondary race to find even more ways to use this newfound power. Soon, steam was not just pumping water or blowing air into furnaces. It was grinding grain into flour, spinning cotton into fabric, and eventually pulling heavy trains across entire continents and pushing massive ships across the vast oceans. However, this transition was not easy or painless for everyone. While some grew incredibly wealthy and the general standard of living began a slow climb, others found their traditional skills and their ways of life becoming obsolete almost overnight. The machine was faster, stronger, and more consistent than any human hand could ever hope to be. This created a deep and lasting tension that would define the next century of social history. We were learning for the first time how to live with machines that could do the work of 1,000 men, and we had to figure out what that meant for the value of human labor and the structure of society. The race that changed the timeline was as much about social change and the reorganization of humanity as it was about iron, heat, and steam. It forced us to rethink our relationship with energy and our role in the production process. The legacy of these improvements is still visible in almost everything we do today. When we look at a modern power plant or a high-tech manufacturing facility, we are seeing the direct descendants of those first efficient steam engines. We are still obsessed with the same goals that drove the inventors of the 1700s. We want to do more with less. We want to find ways to make our systems more efficient, our energy more portable, and our processes more precise. Our modern drive for automation and energy conservation is just the latest lap in the same race that began in those damp mine shafts centuries ago. The quest to unlock the secrets of the earth and turn them into reliable, manageable power is one of the defining stories of our species. We have moved from the heavy, thundering iron of the 18th century to the silent, invisible flow of electrons in our modern devices, but the underlying logic remains exactly the same. We are always looking for that next breakthrough that will break the current bottleneck and allow us to reach higher and move faster. The steam engine was the first great leap, a proof of concept that we could harness the raw forces of nature to serve our needs on a scale that was previously unimaginable. It taught us that precision matters, that efficiency is the true key to growth, and that the right partnership between invention and commerce can change the entire world. As we look back, we can see how one specific technical race set the entire trajectory for the centuries that followed. It was a moment where human ingenuity, intense economic pressure, and newfound mechanical skill converged to create a spark that lit the fuse of the modern age. We are still living in the heat of that explosion, navigating a world built on the foundation of steam and the relentless pursuit of progress. And that is how the race for steam efficiency set the stage for our industrial world. In the next episode, we will move forward in the timeline to 1895 and explore how a different kind of discovery changed medicine forever through the introduction of X-rays. We will see how this new breakthrough changed the stakes of human health by allowing us to see the invisible. If you enjoyed this journey through technical history, please subscribe for more stories.